In this episode, we're going to do a basic router configuration review. I'll show you how to do it, and we'll talk about the concepts along the way. This activity requires us to configure a router using settings from some addresses and some specifications. One router and the devices connected to it have already been configured for us. This is a comprehensive review of previously covered iOS commands. Now, in the first part, we'll complete basic configurations and interface settings on the router. In the second part, we'll use SSH to connect to the router remotely and utilize the iOS commands to retrieve information from the device to answer some questions about the router. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Basic router configuration review. I got the Packet Tracer Lab open. On the left side, I have our work area where we can do all of our configurations and test that we did everything right. On the right side, I have the instructions. On the very bottom right down here, I have the actual Packet Tracer activity window that pops up that has the instructions. In the majority of the right, the upper right, I have the Word document of those same instructions. Reason I have the Word document is we got to answer some questions as we work through it. The Word document will allow me to put my answers in and save it. We have our addressing table. We're going to be referring to this as we go through and configure it. Notice R2 has several interfaces we're going to configure, IP version 4 and IP version 6. With IP version 6, we have our global unique addresses. Global unique addresses start with 2001. And then we also have our link local addresses. Those link local addresses start with FE80. PC 1 through 4, we have IP version 4 and IP version 6 addresses for them. The background scenario for this activity is we're going to be configuring R2, where everything is red connecting to it. We're going to be configuring R2 in all of those interfaces. R1 and all the other devices are connected, are configured, except for some IP addresses on the PCs we have to configure. We'll set that all up, and then in part 2, we're going to use SSH to utilize some iOS commands to get some information off of that. Our instructions, part 1, configure devices and verify connectivity. Step 1, configure the PC interfaces. First thing we got to do is configure the IP version 4 and IP version 6 addresses of PC3, and then we got to do PC4 as listed in our addressing table. I'm going to scroll up. Here's our addressing table. Here's the information we are looking for. I'm going to go ahead and set that. I'm going to click on PC3 right here. Opens up our window. I'm going to click on the desktop tab. And then in my desktop tab, I am going to click on the IP configuration app. Right here, we can see we got IP version 4, we got IP version 6. We have to go in there and set those up. Our IP version 4 address, and we're on PC3, is right here, along with our IP version 6 and our default gateways. IP version 4 address for PC3 is 10.0.4.10. And that's a subnet mask of 255.255.255.0/24. Default gateway for PC3 is 10.0.4.1. Once again, our default gateway is the exit off of our network onto another network. It's that IP address that's on an interface of a router that's on our network. And that router will allow us to get to other networks. Takes care of our IP version 4 information. Let's do our IP version 6 information. First one we set up here where it says IP version 6 address, that is our global unique address. Our global unique address is 2001:DB8:ACAD:4:10. And then we put our prefix in that next field right here. and our prefix is a /64. Half of our 128-bit IP version 6 address. Our link local address is automatically generated for us. Last thing we have to fill in is our IP version 6 default gateway, and that would be right here, this information. Our IP version 6 default gateway is 2001 colon, nope, wrong field. I was looking at the wrong field. Our default gateway is the link local address of our router interface. This is the link local address on our router interface. How we know it's link local starts with FE80. So our IP version 6 default gateway is FE80 : 2:A. Verify all, looks like our information's set correctly. I just click in another field to make sure that that information is set. I'm going to go ahead and minimize PC3. Let's go ahead and do PC4. Click on PC4. Click on the desktop. Click on the IP configuration app. Here's our configuration information. IP address is 10.0.5.10. That's a /24 again, so 255.255.255.0, and our default gateway is 10.0.5.1. No DNS server. That takes care of all of our IP version 4 information. Onto IP version 6. IP version 6 information right here with the default gateway. IP version 6 address is 2001 :DB8 :ACAD :5 : that's a double colon 10. Go to the next field. I just hit tab to go there, and it puts in our prefix 64. Our link local address is automatically generated for us. And finally, our default gateway. Default gateway is FE80 : 2:B. That is the address on our router for that local area network. Go ahead and minimize that. Scroll down to our instructions. That takes care of part 1, step 1. On to step 2. On the router 2, open a terminal. Move to privilege exec mode. So on R2, I'm going to go ahead and click on R2. Slide this up. I make this window bigger. Click on the CLI. The reason I make it bigger, if it gets smaller, it starts to wrap weird, so I make it a little bit bigger. And now hit return to get started. Move into privilege exec mode, type enable. Do that. Notice our prompt changes from the greater than sign to the pound sign, hashtag, whatever you want to call it. I personally call it the waffle sign because it looks like a waffle. Step 2B, enter configuration mode. Go ahead and type config T. Gets us into configuration mode. Assign a device name of R2 to the router. R2, to change our device name, we use the command hostname. Put a space, and then anything we put in there will be the new name of our device. They want us to call it R2. And notice we went from it saying router right here. Now it says R2. That's one of the first things I do to make sure I differentiate what device I'm connected in, because after a while, these terminal windows all look the same. Takes care of 2C. On to 2D. Configure Cisco1234 as the encrypted privilege exec mode password. In order to do that, that is enable secret, then lowercase c, the number 1, SC, all in lowercase, 1, 2, 3, 4. That's that privilege exec mode password. Step 2E, set the domain name of the router to ccna-lab.com. That's part of the IP suite we're looking at. So we start off with IP space domain dash name, and then we put that name in there, ccna-lab.com. And in true Cisco iOS fashion, no news is good news. If I would have typed something wrong, it would have let me know. It would have gave me an error, gave me something saying you typed in something wrong, you're missing part of a command, you have an incomplete command. But if I type in everything correctly, Cisco is just going to sit quietly. It's not going to let you news. So with Cisco and working with the operating system, no news is good news. That takes care of step 2E. Onto step 2F. Disable DNS lookup to prevent the router from attempting to translate incorrectly entered commands as though they were host names. Ever type in a command wrong and it tries to resolve it? That's what's happening. Now, to disable that lookup, put the word no. And then once again, this is part of the IP suite. So it's no IP. We're dealing with the domain processes, and then lookup. That will stop an incorrect term from trying to be resolved. Step 2G, encrypt plain text passwords. Some of your passwords are stored in plain text. If they are, this is going to encrypt them. Well, technically hash them, but it will make the person looking over your shoulder, it'll make it more difficult for them to remember that. Now, in order to do that, it's part of the service. It's a service that is running on your system, and then it's password dash encryption. That's 2G. Onto 2H. Configure the username SSH with an encrypted password of 55H-admin. Now, in order to create that, we are going to go username. Then what do you want to call that user? We want to call it capital S, capital H, admin, space, and then you can either put secret or password. If you put password, the password will be stored in clear text. If you put secret, it'll encrypt that. And so we'll put secret, and then 55, capital H, lower a, lower d, lower m, exclamation mark, lower n. That creates the user. Onto 2I. Generate a set of crypto keys with 1024-bit modulus. That's part of our crypto set. So it's crypto key generate RSA. I spell RSA right. So crypto key generate RSA. Then it's going to ask you how many bits in the modulus. The default is 512, but a lot of people consider that insecure. It's not complex enough. That's why they tell us to use 1024, and a lot of SSH clients won't use 512 keys. They need to be at least 1024 because they say that's more secure. They go ahead and generate the key here, and that takes care of 2I. Onto 2J. Assign Cisco as the console password. Configure sessions to disconnect after 6 minutes of inactivity. Enable login. Then, to prevent console messages from interrupting commands, use the logging synchronous command. Okay, let's do the first couple ones. Assign Cisco as the console password, so we need to get into the line console. So it's line con 0. Notice it tells me SSH has been enabled. So we have linecon 0. Then we want to use the password of Cisco. So password Cisco. That sets the password as Cisco. Now we have to go ahead and tell it to use the login, or use that password during the login process. We want to disconnect after 6 minutes of activity, and that is an exec dash timeout, and then you can put minutes and hour, or sorry, minutes and seconds in there. And so we want 6 minutes and then space 0 seconds. That's our timeout there. And the last thing is to prevent console messages from interrupting commands, use the logging synchronous. Logging synchronous. Spell synchronous correctly. And I still spelt it wrong. Logging synchronous. And here's a great example. I typed in the word synchronous wrong. Cisco was gracious enough to tell me you did something wrong. They put a little caret mark in here saying right about here there's a problem, invalid input. Look there, sure enough, I do have it spelled wrong. I hit the arrow up, I left arrowed over, I made the correction, I hit enter, I spelt it correctly, and what do you know? When I did it correctly, Cisco didn't tell me congratulations. It was just quiet. So we did logging synchronous. That takes care of 2J onto 2K. Assign Cisco as the VTY password. Configure the VTY lines to accept SSH only. Configure session to disconnect after 6 minutes and enable login using the local database. Okay, we can change right into that line. So go line VTY 0 space 4. You could do 0 space 15. So we're now configuring our virtual terminals. First thing it says is assign the Cisco password. So password Cisco, right? And so that sets the password as Cisco. Next, configure sessions to disconnect after 6 minutes activity. That's the exec-timeout command again. And then it's minutes space seconds, so 6 minutes and 0 seconds. Then we have, okay, where are we? Accept SSH only. So that's part of the transport command. So transport, and then we want to change the input to be just SSH. If we wouldn't do anything there, it was telnet. We could put telnet in there, but because we want to be secure, we want SSH only. We're not going to list anything else. And then we're going to tell it to enable the login using the local database. And so login local, and that will be using that user we created a couple steps earlier, that SSH admin. And that's the only user we have set up. Takes care of 2K onto 2L. Create a banner that warns anyone accessing the device that unauthorized access is prohibited. Note, the banner of the message day must include the word warning to be scored correctly. So capital, all caps, warning. Now, to do the banner message of the day, we have to get the global configuration. So go ahead and type exit once. From here, we can type banner, MOTD, and then we put in our delimiting characters. You got to have the same character at the beginning of the end of the message. Let's use the $sign here. So shift 4 gives us a $sign. Then we put what wants to be, or what's going to be printed out when somebody connects in prior to logging in. You want that warning there, because if you don't have that warning, somebody breaks into your system, they go, oh, I didn't know I wasn't supposed to be here. Some people have gotten away with that. But so you want that warning there. It's best to have your lawyers look at the banner message of the day, make sure it covers all the bases. But here we have banner message of the day. So make sure you put in the word warning in all caps, spell it correctly, and then authorized access only, exclamation mark. And then you have to put our ending delimiting character. So I started with the $sign after I did banner message of the day. Now I put the ending $sign in there. I hit enter. No news is good news. On to step 2M, enable IP routing. Once again, enable IPv6 routing. By default, IPv6 routing is not enabled. We have to turn that on the switch. How we do that is IPv6, and then we put in unicast -routing. That turns on IPv6 routing. On to step 2N, configure all 4 interfaces on the router with the IPv4 and IPv6 information from the addressing table above. Configure all 4 interfaces with descriptions. Activate all 4 interfaces. Now I'm going to scroll up to our addressing table. here's our four interfaces: G00, G01, S010, S011. Those are all four interfaces. We need to configure them. Once again, I got to scroll down here. See, what are we configuring? IP version 4, IP version 6, addressing. Configure all four with descriptions and activate all the interfaces. So we need to make sure we put descriptions and activate all the interfaces. I'm just going to start at the top of the list and work my way through. So interface G0/0/0. Now I'm configuring that interface. First thing is set my IP addresses. IP space address, that's for our IP version 4 addresses. That gives us 10.0.4.1. Then we have to put in our subnet mask. Subnet mask of a /24 is 255. Whoops. Start that over. 255, 255, 255.0, 3 255s. Then we put in our IP version 6 address. So we start off by IPv6. To put in your global unicast address, we now go ahead and put that in there. That would be the 2001 here. So 2001 colon DB8 colon ACAD colon 4 double colon 1, and then we put in our prefix. That once again signifies where the network portion is for your IP version 6 address and where the host portion is. Right now we're using a /64, half of our available 128 bits in our IP version 6 address. Now Cisco was kind enough to tell me I did something wrong. I forgot the word address in there. So what I'm going to do is hit the up arrow once, left arrow over, type the word address, put a space in there, and then hit enter. I've set my IP version 6 address. Then we also need to set the link local address for IP version 6. That goes IP version 6 space, and then you put in your IPv6 address, FE80 ::2 :A. Now, instead of specifying a prefix, what you do is now you say link local. So link dash local. That sets that link local address. And once again, I forgot the word address, so I'll hit up arrow once, left arrow over, address space. I did the correction, and Cisco lets me know I did a good job by not saying anything. I set all three of my addresses for gig 000. Let's go ahead and do gig 001. So I can type in interface gig 0/0/1. Set the IP version 4 address, IP space address of 10.0.5.1 with the subnet mask of 255, 255, 255.0, 3 255s. Set our IP version 6 global unicast address, IP version 6 address 2001 DB8 ACAD 5 :1 /64 for our prefix. And then we set our link local address. So IP address, IP version 6. So IPv6 space address space FE80 ::2 :B, and then link dash local. If the link local address, you put that in there. If it's a global unicast address, you put your prefix. Set all three of my addresses for gig 001. Let's go ahead and do interface serial 0/1/0. IP address, and our IP version 4 address is 10.0.3.2 with a /255, or sorry, /24, which is 255.255.255.0. IPv6 address for our IPv6 global unicast address, which is 2001 :DB8 :ACAD 3:2/64. Oh, look at that. I have, for some reason, I put quotes instead of colons in there. I need to go back and change that. It must have been off a key. There we go. Hit enter. I did it correctly. No news is good news. And let's go ahead and set our link local address. So IPv6 space address space FE80 ::1:C and then link dash local. All three addresses are set for serial 010. Let's go ahead and set serial 011. Interface serial 0/1/1. IP address of 209.165.200.255. And then the subnet here is a /30. If you remember, a /30 is 255, 255, 255, 255, and then in the fourth and last octet, it's .252. So let me make sure I got my correct IP address in there. 225, I had that typed wrong. Okay, so 209.165.200.225, and then a /30, which is 255.255.255.252. Let's go ahead and set our IP version 6 global unicast address. So IPv6 address of 2001:DB8:ACAD:1:10. And our prefix for the global unicast address is a /64. (2001:DB8). Oh, I typed in the wrong address. I put ACAD. It's not ACAD. It's feed:224. Now, to get rid of this address, I need to type the word no in front of that. Thankfully, what I can do is I can up arrow once, left arrow over to the beginning, type in no, and then a space, and then the rest of it will stay the same. That removes it. Now let's go ahead and set it again. So IPv6 address of 2001:DB8:FEED:224 :1, and then our prefix of /64. Last thing we have to do is set our link local address here for serial 011. IPv6 address FE80 ::1:D, and then because it's link local, we put link dash local in there. That's our IP address for the fourth interface. We did 3 addresses on 4 interfaces each. That should take care of step 2N. Nope, I forgot the descriptions and I forgot to activate the interfaces. I knew I would do something like that. So I got to go back into each of them, put a description on them, and then activate them. If we look here, I click in the window, mouse over it. This is G000. This is G001. This here going to the internet is S011. This is S010 going to R1. And so let's go ahead and enter in our descriptions. First one here is G00. Go ahead, go into the interface. So interface G0/0/0. Description of, once again, that goes up to switch 3, connection to S3. And then we have to activate it. We activate it by doing the no shutdown command. So no space shutdown. Notice we now change state to up and up. We're looking pretty good. If we look at our topology, notice the connection's up. The switch has got to go through its negotiation process, so it may take up to 30 seconds. If I get impatient, I can come down here, click the fast forward button. I clicked it once, and now everything is up and running. Now we have to go around and put a description and activate the rest of these. This here is gig 001. So let's go ahead and go into that interface. So interface gig 0/0/1. Put in our description. Connection to, and that's to S4. Then we have to activate it. We activate it by doing the no shutdown command. Change state to up, up. That's what we're looking for. Notice it's a green triangle here. Switch is negotiating the connection to make sure there's no trunking, what the duplex is, what the speed is. It'll come up to a green triangle eventually. Then we come over here. Let's go ahead and do this one, the serial 010 interface. And so interface serial 010. Let's put a description in here of connection to R1. And then we have to activate it, do the no shutdown command on it. Notice that connection went up as soon as we did that. Now we changed state to up. Let's go ahead. We're up and we're up. So we change state to up, up. And let's go ahead and do the serial 011 connection. So interface serial 0/1/1. Give us a description. Connection to internet. And then we have to activate it. No space shutdown. Interface change state to up, and line protocol change state to up. So we have up, and we have all green lights on our topology. I'm going to minimize our R2 windows. Let's scroll down, see if there's anything else, and save the running configuration to the startup file. I'm going to open up R2 again. Command to save your configuration is you're going to copy your running -config to your startup -config. Your running config is stored in RAM. If you lose the power, everything in RAM is gone. So you copy it to the startup, which is in flash. And if you lose power, it's still on there. It's like a flash drive or a thumb drive. You can pull it out of the computer, you can plug it back in, you take away power, put power to it, and it will still have your information. And so that way we copy what's in memory in the RAM to the flash, and that's what we're doing. That's how we save our configuration. I'm in the wrong mode. I need to be in global configuration mode. No, I don't even need to be that. I need to be in privileged exec mode. Now I can do the copy running -config space startup -config. It's going to ask destination file. You want that? If that's what you want, all you have to do is hit enter. That's all I'm going to do. And it builds the configuration, copies it over. Now, it's true you could abbreviate this command. Most people do a copy run start. Does the same thing. Notice it gives you the same file name because it knows what you want. When you type in start here, that is unique enough to all the other possibilities. That's all you have to put. Go ahead and hit enter. There is one more thing you could do to save the configuration. That is write memory. Now that command works. That's an older command. It's a legacy command, but they say it's depreciated, that it will be removed in future versions of that. So just get used to using the copy run start instead of the write mem or write memory. So you could either do write memory or write mem. I've seen a lot of people do that, and it does the same thing. It just doesn't ask what file you want. It takes the memory and writes it to flash. That takes care of step 2. Lots of stuff to do there. On to step 3. Now we've got some questions. Using the command line at PC3. So I'm going to go ahead and minimize R2. I'm going to click on PC3. I'm going to click on IP configuration is still open. I'm going to close it by clicking on the X at the right hand side of the blue line there. Closes that. Now I'm going to open up a command prompt. Ping the IPv4 and IPv6 addresses for PC4. Then they want to know, were they successful? So we want to ping 3 to 4. Scrolling up to our addressing table, PC4's IPv4 address is 10.0.5.10. Go ahead and ping that. Ping 10.0.5.10. Looks like the first one's going to fail. Hopefully we're doing an ARP request. That's what it looks like. First one failed. I'm guessing it was doing an ARP request. Next one's all work. I'm just going to verify it. I'm going to hit the up arrow one more time, rerun that command. All 4 should work this time because it's in the ARP cache. We didn't have to go through any lookups for that. Then we want to ping the IPv6 address of PC4. That's right here. Go ahead and in there type ping 2001 colon DB8 colon ACAD colon 5 colon 10. Nope, it's a double colon 10. Double colon 10. And it works right away. Notice we didn't have to do a MAC address lookup. Part of how the ICMP version 6 works is we don't have to have those ARP lookup processes. How they handle that. So we don't have a failed attempt. We don't get a failure for 1 or 2 at the beginning and then repeat it. They will work right away across your network because of how the neighbor solicitation, neighbor request acknowledgements go across our network. So were they successful? Yes, they were. From the command line on R2, ping the serial 011 interface address of R1 for both IPv4 and IPv6. The address is assigned to S011 interfaces R. Oh, that's nice they gave it to us. I'm going to go ahead and minimize PC3. We want R2. So I'm click on R2. We're in our command line here. Should be in privilege exec mode. And go ahead and type ping and then 10.0.3.1. That successfully worked. And let's go ahead and ping the IPv6 address. 2001 colon DB8 colon ACAD colon 3 double colon 1. And those all worked also. So the IPv4 and IPv6 addresses work. Were they successful? Yes, they were. From the command line of PC3, ping the ISP address of 209.200.226. Were the pings successful? Okay, so from command line on PC3, I'm going to go ahead and minimize R2, click on PC3. And I'm going to ping the ISP. And they even give us the address again. 209.165.200.226. And that worked successfully. It was all in the ARP cache. We didn't have to do any ARP lookups. I sent out 4 echo requests. I got 4 echo responses back in. Were the pins successful? Yes, it was. Now, once again here, what happened is PC3, to get off the network, had to go through its default gateway, which is right here. And then this router, R2, sent the request on, they got the response, and it came back. From PC3 PC3. Attempt to ping an address on the ISP for testing. 64.100.1.1. Were the pings successful? And so what we want to do from PC3 here is ping 64.100.1.1. We sent for, we received for, we lost for, 100% loss. We were not successful. No. Why weren't we successful? Okay. We are pinging from PC3 to the far side of the internet. Up here, ping PC3, the ISP address of 209.165.200.226. That address is right here. Now, it failed because we don't have routing established. There isn't a route here, either a default route, that gateway last resort. We don't have a routing protocol running to get to this address. We do not have routing there. We do not have routing set up. There's no default gateway on R2. And so that's why it did not work. On step C, from the command line of PC3, that's what we have right here. Open an SSH to R2 gig 001 IP version 4 address and log in as the SS admin with the password of 55H admin. They were even nice enough to give us the command here. Once again, notice we are on the command prompt inside of Windows. That's right where we are here. Now we type in SSH space -L. That's not a 1, that's a -L for login. Then we put our username, capital S, capital H, lower a, lower d, lower m, lower I, lower n, and then the IP address of who we're trying to connect to. We're trying to connect to the IP version 4 address on R2 of G000, which happens to be 10.0.4.1. Then it's going to prompt us for the password. Our password that for the user we created was 55 capital H, lower a, lower d, lower m, exclamation mark, lower n. Go ahead and hit enter. And notice it gives me a warning. Authorized access only. Was the remote access successful? Yes, it was. Part 1 is done. On to part 2. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. In part 2, you'll use show commands from an SSH session to retrieve information from the router. Establish an SSH session to R2. That's what we did up here in this last step. It is still open, so we can go ahead and use that. If you don't have that open, just scroll on up, open up PC3, get into your command line, enter this command in, and then add this password. But seeing as we didn't close out this window, we are still there. On to part 2, step 1. We establish that connection. Now part 2, step 2. Retrieve important hardware and software information. Use the show version command to answer the questions about the router. What is the name of the iOS image the router is running? Okay. We can come over here. We have to be in privileged exec mode, so go ahead and type enable. That was a password we set up. Our password was Cisco1234. That is a lowercase c, the number 1, lower s, lower c, lower o, 1, 2, 3, 4. There we are. Notice our prompt has changed. It now says R2 with the # hashtag, my personal favorite, the waffle sign, or I guess the technical name is the octothorpe of that. So we are now in privilege exec mode. We can now enter in the show version command. So show space version. And you can see here, it gives us a whole bunch of information. Some things here it'll show us is we have all this information, and then we have the more, meaning there's more information to display. How we can do that is either hit enter and it goes up one line at a time, or if you hit the space bar. I'm going to hit the space bar once. Notice we're on importers right here. Hit the space bar. Now importers are all the way up there. It scrolls an entire page of information. Hit the space bar again and again. And the question here was, what is the name of the iOS the router is running? The iOS image the router is running. If we look up here, system image file is, this is the location, but this is the name of that file. All of that. So what is the model number, the type of the iOS, different versions and subversions of that. And then this specifies it's a binary file. It's an executable. So this is the entire name. We need to go ahead and type that in. So our file name is ISR 4300-universal K9 .03.16.05.S.155 #3 .S5 .ext .S .A .bin. There is the iOS image that we are running. How much non-volatile RAM does the router have? NVRAM. Well, we have to look here, and we are looking for the flash memory. Start up here. This is where we started. Looking through here, don't see any information. Looking. We have some cryptography information. More information about the different packages we have. Coming down. And then right here, this is the non-volatile configuration memory. That's not what we want. We want the flash memory, we want the non-volatile RAM right here. So there are about 32,000 kilobytes. So how much is in there? There is 32,768 capital K bytes of NVRAM. Next question, how much flash memory does the router have? If we look at our output again, we can see that we have physical memory, but then now we have flash memory. Right here's our answer. 322,355.1 kilobytes of flash memory. 322,355.1 kilobytes of flash memory. On to step 2B. The show command often provides multiple screens of output. Filtering the output allows a user to display certain sections of output. To enable the filtering command, enter the pipe sign. That is the key above the enter key, but you have to have shift in. So it's the key above the enter key. You have to hold the shift and then hit that. Followed by a filtering parameter and filtering expression. You can match the output to the filtering statement by using the word include keyword to display all lines from the output that contain the filtering expression. Filter the show version command using show version, and then we have our pipe sign, and we wanted to include every line that has the word register in it to answer the following question. Okay, let's go ahead and type that command in. Show space version space, and then the pipe sign, that's the key above the enter key. You got to hold the shift down, and it's a line going up and down. So that's the pipe sign space, and we want to include every line that has the word register in it. Go ahead and hit enter, and notice there is only one line that has the word register in it. If we go up and look at the original time we ran it, we look at every one of these lines in here. The word register does not appear except for that one single line coming down all the way through here. We still don't have it. After the memory, this is the only place that word register applies, so it gives us that line. It gives us all the lines containing the word register. What is the boot process for the router on the next reload? What is the boot process? Well, the configuration register is 0x2100. So what the 0x means, this is a hexadecimal number. And so we'll say configuration register is 0x2102. Oh, fine, 0. Now, what does that really mean? In most cases, when we have this, the router will undergo a normal boot, load the iOS, and load the startup configuration. And so this means it's a normal boot. If the value was the 2142, it's going to load the iOS, but then it's going to skip loading in that startup config. And that's how you do password recovery, is you skip loading in that startup config. That way you can get into the device without having the username or password to get into it. And so you would set the configuration register to that. But right now our configuration set to 2102, and that specifies it's a normal boot. On step 3, display the running configuration. Use the show running command on the router to answer the following questions, filtering for the lines containing the word password. So now they want us to filter for all lines containing the word password. Let's go ahead and do that. I'm just going to hit enter several times to give us a clear working area. So we want to do a show space running dash config. Yes, I could have just typed the word run in there. And then we want to put a space, a pipe sign in the space, and then we want to include all lines that have the word password in it. And there are 3 lines that have the word password. One is our service password encryption that encrypts all clear text passwords. We have the next line, which it says password 7, and then they give us a hash value, and they also another line that has password 7, and it gives us a hash value. Notice these hash values are the same. Now, what does that mean if the hash values are the same? It's the same password. And so how are the passwords presented in the output? Passwords are hashed due to the password, or sorry, due to the service password dash encryption command. Use the show running config pipe sign begin VTY command. And so we're going to display the show running config, but we're going to filter it, and the first line that has the word VTY on, we're going to start displaying everything after that. Let's go ahead, enter that in. I'm going to hit enter a couple times to give us a clear working area. And so we want show space run. That's the short version of show space running dash config space pipe sign space. And then we want to begin with VTY. Notice we come to the first line that has the VTY in it, and then we display everything else after that. Thankfully, this is typically right at the end of the configuration file. Not a lot to be displayed. What is the result of using this command? Well, the result of this is what we just talked about. Shows the line that has VTY in it and everything else after it. Shows the line with VTY in it and all lines after. Step 4, display the routing table on the router. Use the show IP route command on the router and answer the following questions. Okay. I'm going to come here. I'm going to hit enter a couple times to give us a clean working area, and then show IP route. Here's our routing table. Here's the different codes that are possible. It tells us we have a gateway of last resort, and then it gives us all the networks we know, or that the router knows how to get to. Notice we have our parent commands. The parents all have some child commands with them. So what code is used in the routing table to indicate a directly connected network? We can go up here and find that. Up here we have the L for a local connection. We have the C for our connected networks. This is our directly connected network. C is for connected. And so it is a C. C designates a directly connected network. When we get into it, the L also signifies a directly connected network. It just happens to represent the IP address of the interface that's on that network. And so C is part of your answer, and L is also the correct answer. So there's two codes here that indicate the directly connected network. L indicates a local interface. And then both answers are correct. Next question. How many route entries are coded with a C code in the routing table? Now, we have to look at the information down here, but we have one C, we have a second C, a third C, and a fourth C. There are 4 entries coded with a C. So 4 is our answer. Step 5, display a summary list of the interfaces on the router. Use the show IP interface brief command on the router to answer the following questions. Okay, let's go ahead, enter in that command. Oh, sorry, we got to do that on a router. So show IP interface brief, and it lists that out. This is an example here of why I make my window a little bit bigger. If you didn't make it bigger, it's going to wrap a little bit weird and it's harder to see. You can see that some of the stuff goes down to the next line. When you bring it over, it lays it out a lot easier to read. Everything lines up nicely in a column. So I bring these windows open a little bit wider. Now, on the question 5A, or the first one, what command changed the status of gigabit Ethernet ports from administratively down to up? So this one, VLAN 1, is administratively down. If these were administratively down, your gigabit and your serial ports, how would you bring them up? Well, if they're administratively down, that means somebody turned them off. Somebody did a shutdown on it. What command would you do to make them come back up to activate them, that would be the no shutdown command. And so we would do a no shut down. Once again, that shouldn't be capitalized. Windows automatically capitalizes it, but it's no shutdown. What filtering command could you use to display only the interfaces with addresses assigned? Well, we would use this command. So show IP interface brief. Show IP interface brief. Space, pipe sign, space. And then we want to see only interfaces with addresses assigned. Now, you can't filter on more than one command, so you can't say, give me all of the addresses that have 10.0.4.1 and 10.0.5.1 and 10.0. You could say, give me all the addresses that have 10 dot in them, but what happens when you get down to here? What we can do is say, instead of display all the lines that include it, you can exclude it. And right here is an unassigned one, so you can say exclude everything that's unassigned. So it would be exclude unassigned. That command would give you all the lines except for the lines that have unassigned in it. And once again, it should be a lowercase s. Windows took care of that. On to step 5b. Use the show IPv6 interface command, or interface brief command, to verify IPv6 settings on R2. Let's go ahead and enter that in. I hit enter a couple times, give me a clear working area. So show IP. And this is the change for IPv6. So it's show IPv6 interface brief. Right here is all of our interfaces. It lists our link local addresses. It links our global unicast addresses, and then it gives us our status, up and up, our status and our protocols. What is the meaning of the up part of the output? Well, what we just talked about. The up status reflects the layer 1 and layer 2 status of the interface and does not rely on layer 3 for status. So it's the status and then it's the protocol. That was Packet Tracer Lab 14.3.5 Basic Router Configuration Review. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.